There is a water tank in a small town outside Naples that has held drinking water for 2,040 years. It is bigger than a basilica. It cost the Romans almost nothing to line, and the recipe for the material that makes it waterproof is sitting in a book that has been in print since 1547. A modern concrete water tank, the kind your county will permit, lasts about 50 years before it cracks and leaks. A plastic cistern lasts 20. A galvanized steel tank lasts 30. The Roman version has outlasted the empire that built it. Archaeologists at the Cambridge European Journal of Archaeology rebuilt the mortar in a lab 2 years ago. They confirmed what farmers in Spain, Portugal, and North Africa have known for centuries. The lining costs about $8 to mix per square foot at modern hardware store prices. It self-heals, it improves with age, and it can store rainwater clean enough to drink for an entire year without a single chemical additive. You have never seen one in a modern American home. That is not an accident. For the next 15 minutes, I am going to show you the exact materials, the exact ratios, and the exact build process the Romans used. By the end of this video, you will be able to estimate the capacity, the cost, and the lifetime of a cistern for your own property, and you will know, with hard numbers, why the modern water utility industry would prefer you never learn this. Stay with me. The answer starts about 2,090 years ago in a town called Piscinum on the Bay of Naples. The Roman Western Fleet was stationed there. 22,000 sailors, hundreds of ships, and one problem: there was no river. So Augustus, the first emperor of Rome, ordered the longest aqueduct in the ancient world. 96 kilometers of stone channel from a spring at Serino, sloping down by gravity, ending at the top of a tough cliff above the harbor. And at the end of that aqueduct, they built something the locals would later call the Piscina Mirabilis, the wonderful pool. It is a single underground room carved into volcanic rock, 70 meters long, 25 meters wide, 15 meters high. 48 pillars holding up the roof. Capacity 12.6 million liters, about 3.3 million gallons. Enough drinking water for 10,000 people for almost a week, with no aqueduct flowing. It was finished around 12 BC. It is still standing. Now here is the part the YouTube engineering channels never explain. The pillars are volcanic stone. The walls are brick. The vault is concrete. None of that is special. You can do any of it badly. The miracle of this building, the reason it has not leaked in 20 centuries, is one thin coat of pink mortar troweled onto the inside walls. The Romans called it Opus Signinum. To your eye, it looks like rough pink plaster. At the molecular level, it is something else entirely. It is lime, mixed with crushed terracotta pottery in a very specific ratio. When water hits the calcium in the lime and the silica in the broken pottery, a chemical reaction starts. The two minerals lock together into a compound called calcium silicate hydrate. That is the same compound that gives modern Portland cement its strength, except the Roman version keeps reacting, for years, for centuries. Meaning, every time the lining gets wet, it gets stronger. Pliny the Elder wrote the recipe down around 70 AD. The Cambridge experiment in 2024 tested 8 different mixes of lime to sand to crushed pottery. The team confirmed that the right ratio creates a surface so dense that water consumption through the lining drops to nearly zero within the first few months of use. The physics do not negotiate. You cannot evolve around a chemical bond. The lining does not biodegrade. It does not rust. It does not need a service contract. There is no filter to replace. There is no membrane to puncture. There is no pump motor to burn out. It is just stone, slowly turning into harder stone. And here is where the conspiracy starts. The average American household pays $73 a month for water. A family of 4 in California pays $77 a month. A family in West Virginia pays $91. That is between $876 and $1,100 a year, just for water. Over a 30-year mortgage, that is between $26,000 and $33,000 for something that falls out of the sky onto your roof for free. A 2,000-gallon Roman cistern, sized for a family of 4, costs about $8 per square foot of lining at modern Home Depot prices. Total materials around $300 for the full build, including hydraulic lime, crushed terracotta, sand, and the food-grade collection components. So why is every house in America plumbed to a municipal water line? Why is the bottled water industry worth over $300 billion worldwide? Why does the average American buy 167 plastic bottles of water a year at a markup of 2,000% over tap water, which itself was free water you already paid a utility company to deliver? Why has Colorado, until 2016, made it functionally illegal to collect more than 110 gallons of the rain that falls on your own roof? You already know the answer. It is not because the design does not work. The Romans built 10,000 of them across 3 continents, and 100 of them are still functional today. It is because a water tank that lasts 2,000 years, costs $300 in materials, and requires no monthly bill, is a terrible business model. That is not a coincidence. Here's how you build one. Step 1. Sizing. A family of 4 uses about 300 gallons of water a day for everything, including showers, laundry, and the toilet. For drinking and cooking alone, the number drops to about 8 gallons a day, 32 gallons for a family of 4, roughly 12,000 gallons a year. A standard asphalt shingle roof of 2,000 square feet in a region with 20 inches of annual rainfall collects about 24,000 gallons a year, twice what you need for drinking, with overflow to spare for the garden. So your target cistern, size for drinking and cooking with a 6-month safety margin, is around 6,000 gallons, a round chamber 8 feet across and 12 feet deep buried in the yard, or a rectangular concrete box 10 feet by 10 feet by 10 feet half buried. Step 2. The shopping list. Hydraulic lime, which is sometimes labeled natural hydraulic lime or NHL 3.5, is available at any masonry supply yard for about 30 cents a pound. You will need roughly 200 pounds for a 6,000-gallon cistern, $60. Crushed terracotta, called shamat by the archaeologists, comes from broken clay pots or unglazed clay roof tiles. Free if you scavenge. About 40 cents a pound new from a pottery supply store. You will need roughly the same volume as the lime. Another $60 worst case, mason sand, the fine kind, not concrete sand. About $6 a 60-pound bag at Home Depot. You will need 3 bags, $18. The structural shell of the cistern can be poured concrete block, or even bricked masonry. Standard Quikrete, $8 a bag, 25 bags for a 6,000-gallon vault, $200. A first flush diverter, which is the modern equivalent of the Roman Piscina Mirabilis, the small settling basin in the floor of the Piscina Mirabilis. It throws out the first 10 to 15 gallons of dirty water off your roof at the start of every rain. $38 on Amazon. A simple ceramic candle filter for the final drinking water, the kind used in Berkey-style countertop filters. $45. This is the only consumable in the whole system. One candle filter lasts about 18 months. A solar-powered shallow well pump if the cistern is buried and you want pressure at the tap. $80 at Harbor Freight. Optional. The Romans used gravity. Total materials cost for the full system, around $410. The $8 number in the title is the cost of the lining alone, the part that the Romans considered the actual technology. Everything else is just the box that holds the water. Step 3. The build. Dig the hole. 6 feet deep, 10 feet by 10 feet square, with a 1-foot drainage channel sloping toward one corner. This is your Piscina Mirabilis. The Romans figured out that sediment always collects in the lowest point, so they built that point into the floor on purpose with a drain plug. You can clean 2,000 years of mud out of one of these cisterns in an afternoon. Pour the structural shell. 6-inch thick walls, 8-inch thick floor reinforced with rebar. Standard residential pour. Cure for 14 days. Now the part that ruins 90% of DIY cistern builds, the lining. Most people, when they try this, treat the inside of the cistern like a pool. They paint it with rubberized waterproofing. They coat it with epoxy. They drop in a plastic liner. All 3 of those things will fail in under 10 years. The pool paint cracks. The epoxy delaminates from the concrete underneath. The plastic liner punctures or leaches phthalates into the drinking water. The Roman lining does not seal the surface. It becomes the surface. It chemically bonds with the calcium in the underlying concrete and creates a single integrated layer that gets denser over time. Here is the ratio that the Cambridge experiment confirmed as optimal. 3 parts hydraulic lime, 2 parts mason sand, 1 part crushed terracotta by volume. Mix it dry first, then add water slowly until it has the consistency of cake frosting, not soup. Frosting. Trowel it onto the inside walls and floor in a layer about ½ an inch thick. Work in one section at a time so the lime does not start curing in your bucket. The first coat will dry to a dusty pink. After it dries for 48 hours, polish the surface with a damp sponge. This closes the pores. The Romans called this technique smoothing, and it is the difference between a cistern that holds water and a cistern that weeps through every microcrack. Let the lining cure under wet burlap for 21 days. Spray it with water twice a day. This is not optional. Lime cures by hydration, not evaporation. If you let it dry too fast, it will be brittle. Slow and wet is the entire trick. After 3 weeks, fill the cistern with rainwater. Run the first full tank to the garden, the second full tank too. By the third fill, the lime will have leached out enough of its initial alkalinity that the water inside the tank will sit at a pH of around 7.5. Slightly basic, drinkable. For potable use, run the output through a single ceramic candle filter at the tap. That is the entire treatment train. Step 4. The connection. Roof gutters feed into a downspout. Downspout feeds into the first flush diverter. The diverter dumps the first 10 to 15 gallons of dirty rain into the garden, then automatically switches the flow into the cistern intake. Inside the cistern, the water lands on a calming inlet, which is just a 90-degree pipe elbow pointed sideways, so the incoming water does not stir up the settled sediment on the bottom. The output is a tap at the height of about 4 inches above the floor of the cistern, never at the bottom. The bottom is where the sediment lives. The Romans figured this out 2,000 years ago, and modern plastic tank manufacturers still get it wrong on entry-level tanks. For variations, if you live in a freeze zone, bury the cistern below the frost line, which is between 3 and 6 feet depending on your latitude. If you live in a high rainfall zone like the Pacific Northwest, downsize to 4,000 gallons. If you live in the desert, increase your roof catchment area instead of the tank size. A bigger roof beats a bigger tank, almost every time. Now here are the real numbers from real builders. A family of 4 in Central Texas, documented in a Texas A&M extension report, has been running a 4,000-gallon cistern with a hydraulic lime lining for 11 years. 0 leaks. Annual water test results consistent with EPA potable standards after ceramic filtration. Total operating cost over 11 years, $67 in replacement filter candles. A homestead in southern Spain, documented in the same Archaeopress volume on Western Mediterranean water systems published in 2025, has been running a Roman-style domestic cistern continuously since 1974. Same lining, never been resealed. Holds rainwater clean enough to drink off the tap without filtration in the dry months when sediment has fully settled. The Wisner Institute, which studies historical water engineering, has measured the surface permeability of original Piscina Mirabilis mortar at less than 0.1 liters per square meter per 24 hours. That is 15 times tighter than the modern EPA standard for potable water storage tanks. 2,000-year-old technology beating the modern code by a factor of 15. The honest limitations. This is not a magic system. There are 3 places it will not work, and you need to hear them. First, if your annual rainfall is under 10 inches and your roof is under 1,500 square feet, you cannot make the math work. Roman cisterns in the Sahara Desert worked because they were paired with massive paved courtyards, specifically designed to channel every drop of dew and runoff into the tank. Without that catchment area, you will not collect enough to drink. Second, if your roof is made of treated metal, asphalt shingle with zinc strips, or any material that off-gases chemicals, the first flush diverter is not enough. You will need either a roof material change to clay tile or metal with food-grade coating, or a charcoal filter stage between the diverter and the cistern. Third, the lime in the lining will leach into the water for the first 90 days. The water will be slightly alkaline. It is not dangerous. The pH at week 2 of a new cistern will hit 9, which is the same as some bottled mineral waters, but it tastes strange. Do not drink it until the third fill and run it through the ceramic filter even then. I am telling you this because this channel always gives you the full picture. A Roman cistern is not a plug-and-play purchase. It is a construction project that pays for itself in 11 months at the average American water bill and then keeps paying for itself for the next 2,000 years. Here is the part that stays with me. 2,040 years ago, an engineer in a Roman naval base mixed lime with broken pots and troweled it onto a stone wall above the Bay of Naples. He probably thought he was just doing his job. He could not have known that his work would still be holding water after the fall of his empire, after the Dark Ages, after the Renaissance, after the discovery of the New World. after the invention of the printing press, the steam engine, the light bulb, and the internet. That knowledge moved through Roman engineers to Byzantine architects to medieval Spanish farmers to North African colonists for 20 centuries. And then in the late 1900s, in the rush to wire every American home to a municipal water grid, the knowledge stopped moving. It did not disappear. It just stopped being profitable to teach. Now, you have it back. You know that $300 of lime and broken pots can replace a $30,000 lifetime water bill. You know that the technology is older than the United States by 1900 years. You also know what a $300 billion bottled water industry depends on you not knowing. If this helped you, send it to the one person you know who is building on land right now. Not everyone, just that one person. Knowledge like this does not disappear on its own. It gets buried. This channel digs it back up. Thanks for watching. I'll see you in the next one.